Hi, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Energy Transfers. This is a student reader in Unit 9. Doing work with machines. Sewing for football players. Marge Switzer sews many football jerseys. Marge is the seamstress for the Green Bay Packers. The Packers are the football team of Green Bay, Wisconsin. Marge has a sewing room across from the locker room. One of her jobs is to mend the players' uniforms. She fixes rips or tears that occur during the game. As a seamstress, Marge uses different tools to help her do her job. One tool is a good pair of scissors. Many people don't think of scissors as machines, but they are. In science, a machine is any device that does work. Work is any change in position, speed, or state of matter due to force. Scissors are a kind of simple machine. Forces on Earth. Remember that a force is a push or pull that acts on an object. Force is always needed to transfer energy into or out of a system. Gravity is a kind of pulling force. Gravity is the force of attraction between all matter. On Earth, the force of gravity pulls all objects near Earth's surface down. Gravity is why a football thrown by a player will fall back to the ground. It is also why we don't all float off into space. Friction is another force that slows motion whenever two objects rub against each other. Friction slows motion because it causes some of the energy of the moving object to change into heat. Gravity pulls down on this ball, causing it to fall to the ground. Simple machines help do work. To understand how scissors use force to do work, we need to begin with their structure. Scissors are made up of two smaller simple machines. A simple machine is any device that helps us do work by redirecting force. We'll use a seesaw to explore this idea further because seesaws are similar to scissors. Both seesaws and scissors use levers to do work. A lever is a simple machine that is made up of a stiff beam that rests on a support called a fulcrum. The beam is called an arm. Scissors are made up of two levers. Seesaws are one lever. They have a simple structure. A long, narrow board is supported by the fulcrum in the middle of the board. Seesaws are levers. They are made up of a stiff beam and a fulcrum. Simple machines redirect force. Levers redirect forces because as one side goes down, the other side goes up. Again, let's look at a seesaw. The seesaw's arm rotates on the fulcrum. This movement is called a pivot. Let's explore this idea a little more. Imagine if just one person sits on the seesaw. The seesaw will be unbalanced. The weight of that person pushes down on one side of the seesaw. The seesaw redirects that pushing force to the other side. This causes the seesaw to pivot on the fulcrum as the other side moves up in the air. We're using weight rather than mass here because we're talking about forces. Remember that weight is the gravitational force exerted on an object by a planet or moon. Weight is calculated by multiplying the object's mass by the force of Earth's gravity. As one side of the seesaw goes down, the other goes up. The seesaw pivots around the fulcrum. Changing the motion of a seesaw. Now, imagine that a second person joins the person already sitting on the seesaw. This second person sits on the other side of the seesaw. The motion of the seesaw changes depending on the weight of the second person. If the second person is a similar weight to the first person, the seesaw will be balanced when both people are an equal distance from the fulcrum. Remember that the forces acting on an object are balanced when they are equal. This seesaw is balanced. To make the seesaw move, there needs to be an unbalanced force. This happens when one person applies a force by pushing down on the ground. This downward push is called the effort force. The effort force is the force that is applied to the simple machine. The effort force transfers through the seesaw to do work. The work it does is lifting up the other side. The person being lifted is a load. A load is an object that a simple machine moves, or the force that the simple machine must overcome. The seesaw can be fun because people on the seesaw take turns applying the force and being the load. The effort force switches sides in a seesaw. What if the person joining the person sitting on the seesaw is an adult and the person on the other side is a child? The adult will weigh more than the child. Because of this, the adult applies more force to the seesaw than the child. This makes the seesaw unbalanced. The child won't be able to lift up the adult. In order for the seesaw to move, the heavier adult would need to move closer to the fulcrum. This would change how the forces are applied. It would allow the child to move the adult on the other side using less force. When the child pushes down on the ground, they apply the effort force. This means the adult is the load. As the distance between the adult and the fulcrum gets smaller, the child needs less effort force to lift the heavier adult. The child can lift a heavier adult using less force when the adult sits closer to the fulcrum. It's important to remember that energy cannot be created or destroyed. This means that levers don't create energy to move heavier objects. Instead, they allow the work to be done with less force by increasing the distance that the force has to travel to do the work. This means that the same amount of work gets done. The lever just makes it easier to do that work. We can understand this with a hammer claw. The claw of a hammer is a lever. It works by redirecting forces so that less effort force is needed. It helps pull nails out of wood much more easily than could be done with your bare hands. Unlike in the seesaw, the fulcrum isn't in the middle of the lever arm. Instead, it's close to the side of the hammer that does the work. The closer the fulcrum is to the load, the heavier the load can be lifted. Scissors. Use simple machines. Now let's go back to scissors. Scissors can cut different materials because they are made of two levers. Each lever on a pair of scissors is a metal blade. This blade has a sharpened edge. They are joined by the fulcrum in the middle of the scissors. Scissors work because as you move the two handles together, you apply an effort force to the scissors handle. The scissors redirect the effort force from the handle to the blades. This causes the blades to move, producing a load force. When the sharpened blades slide against one another, they cut whatever material is between them. So here's a picture of the scissors. The effort, the load arm, load, and the fulcrum. Scissors are two levers joined together. In the know, simple machines all around. Next time you go for a walk, look around. Chances are you'll see simple machines all around. Every time you go up or down stairs or a ramp, you use an inclined plane. An inclined plane is a slanting surface that connects a lower level to a higher level. It is easier to raise or lower a load when you use an inclined plane rather than lifting or lowering the load straight up or down. It is easier because inclined planes increase the distance the load travels. And when you pull a suitcase or push a shopping cart, they move because they use wheels and axles. An axle is a rod that goes through a hole in the center of the wheel. As the wheel turns, it turns the axle. If the axle is attached to an object like a suitcase or a cart, the wheel and axle make it easier to move the object. They help to reduce friction. Here's a picture of an inclined plane. And here is wheels and axles. Have you ever kept a door open using a doorstop? Or dug a hole in the garden with a shovel? If so, you've used another kind of simple machine called a wedge. A wedge is a triangular tool. It has at least one one slanting side that ends in a sharp edge. It separates or holds objects in place. And if you've ever helped to put together furniture or toys, you've used screws. A screw is an inclined plane wrapped around a pole. It holds things together or lifts materials. Finally, anytime you've ridden in an elevator, you move up and down because of pulleys. A pulley is a grooved wheel that raises, lowers, or moves a load. Pulleys are how window blinds, and drapery are opened and closed. Here's a wedge, a screw, and a pulley. Designing a catapult, launching a plane into the air. Airplanes normally need a long runway for taking off. They need space to build up speed. But in the middle of the ocean, planes need less space to take off. They use the deck of a ship called an aircraft carrier. Aircraft carriers are massive. However, they are still much shorter than a regular airport runway. On land, airplanes need a long runway to take off and land. These planes can take off from the deck of this aircraft carrier. Catapults launch objects. Airplanes can take off from the ship because of catapults. A catapult is a machine that changes potential energy to kinetic energy so it can launch objects into the air. To launch means to throw something with a lot of force. Remember that energy can either be stored or in motion. Energy that is stored is called potential energy. The energy of motion is called kinetic energy. There are different forms of potential and kinetic energy. Chemical energy is one form of potential energy. It is stored in the bonds that hold together atoms and molecules. All moving objects, from a moving car to a running dog, have kinetic energy. Food contains chemical energy. Catapults can use different forms of potential energy. For example, some fishermen use catapults to launch bait into the water. Bait is used to attract the fish they want to catch. The catapults used by fishermen are simple. They are made up of a kind of rubber band. This rubber band stores elastic energy. Elastic energy is a form of potential energy. It is stored in objects when they're stretched. The more the rubber band is stretched, the more elastic potential energy it stores. In the catapult used in fishing, the bait is placed at the end of the rubber band. When the rubber band is released, the elastic potential energy changes to kinetic energy. This energy launches the bait into the water. These catapults change elastic potential energy into kinetic energy to launch bait. A brief history of catapults. People have used catapults since the time of the ancient Greeks. One common ancient catapult was called a trebuchet. A trebuchet used a lever and a sling to throw heavy stones at enemy castles or walls. The trebuchet moves in a similar way to a seesaw. On one end moves up as the other end moves down. However, there are some differences. The first difference is that the fulcrum isn't halfway between the effort force and the load, as it is in a seesaw. Instead, the fulcrum in the trebuchet is located closer to the side where the effort force will be applied. This makes one side of the lever arm shorter than the other. There is a heavy weight called a counterweight. It is attached to the short arm of the lever. The load is the object to be launched. It is on the opposite side of the fulcrum. It is usually placed in a sling at the very end of the long arm of the lever. Energy changes in a trebuchet. Trebuchets launch heavy objects like rocks because they change gravitational potential energy into kinetic energy. This gravitational potential energy comes from the counterweight. When the counterweight is pulled up off the ground, it gains gravitational potential energy. The higher off the ground it is, the more energy it stores. Also, the more massive it is, the more potential energy it has. When the counterweight is dropped to the ground, gravity pulls down on it. This causes the gravitational potential energy to change into kinetic energy. This kinetic energy pulls down on the lever. This causes the long arm to move up as the short arm is pulled to the ground. As the long arm moves up, it launches the sling, holding the load. The trebuchet before launch, the trebuchet after launch. Energy conservation. The more potential energy a catapult can store, the more kinetic energy it will have to launch its load. This is because energy is always conserved. This means it isn't created or destroyed. When engineers design catapults, they need to know that energy cannot be created or destroyed. They need to think about the form of potential energy they want to use to change into kinetic energy. They also need to know about friction. Friction occurs wherever two objects rub against each other. Friction transfers energy out of systems. Engineers try to reduce friction in places where two objects come into contact with one another. This is because they want as much potential energy as possible to change into kinetic energy. Engineers often have to test more than one prototype. With each test, they look for ways to increase the energy their design can store and change into kinetic energy. I learned a lot reading energy transfers, and I hope you learned a lot too. I'll see you tomorrow with another one. Bye.